So it started recording now. Yeah. So I'm Junjun, and this is Lab9, and I will do the first part in Lab9. Let me share my screen. Yeah. As we can see, we are doing Q learning, reinforced learning in a path finding game, and I follow the instruction from the PDF. Uh, um, there are uh, four actions with up, down, left, and right, and uh, and we follow the parameters the instruction gave us. This learning rate is equal to 0.1, and gamma is equal to 0.9. Also, the epsilon we also start from 0.9 and end at 0.1. And yeah, our approach is like 500. Also, for yeah, these are choosing action and updates parameters. Yeah, and also as preparing for the part two, we also save the part ones, like if the total let me check, it's like 200, I think. Yeah, if successful less than 200 steps, we will save it into local uh into no local document. And yeah, and let's try running it. As we can see, this first picture is for the training, the epsilon and the total reward per epsilon. Yeah, and the next picture, we will show the final result using after training, the final path we found in part one. Yeah. Let's move on to deal.
So for part two and part three, we are running on Rose's local computer, and I'll first show. For our Lab9, the milestone one and milestone two, three, they are separated. So the learned paths we saved for milestone two is kind of different to what Jason just showed, and let's run the milestone two code first and show the here is the learn pathway used for milestone 2. Yeah, and the main size we use is 5 times 8. And then this is the performance. This is the training rewards for milestone 1 versus milestone 2. We can see after we use the saved path from milestone 1, the rewards uh, increase significantly from the beginning of our training. And then the next part is for milestone 2. We add in neural network to milestone 2, and those will show that.
Okay. Okay, so now I'll run milestone 3. We're using a 5 by 8 maze grid. So what we're doing is first we are running all the three milestones in order to have a proper comparison. And then now we're gonna be running milestone 3. So you can see it's running on CUDA. So we can see we're running thousands of rewards, right? And we have 10 epochs. Okay, so now our neural net it ran for 1,000 episodes. So I will show you the outputs. So here we have the path of the milestone 1, milestone 2. Okay, over here you can see the path is the same because milestone 2 basically gets the history from milestone 1 and then learns. And then over here we have our neural net and it's a different path. Now I'll show you the comparison. First, before that, we'll go to the individual parts. So over here we have the three different graphs. Over here we can see that what you can see the different the fluctuations is basically the actual rewards. That's the actual reward part that is okay, it's hit a wall, that's why it's gone negative. And then when it reaches the goal, it basically goes to positive. And then the orange line is basically the average for better comparison. Over here we can see that so these are the three different graphs, and then over here now we'll just compare the average. So over here you can see that our neural net in the beginning it's actually much worse than the Q learning and the history, but gradually it basically over time it smooths out and it becomes stable. Our yeah, so it basically stabilizes over time and it gives a better performance, or I would say equal performance to historical learning and Q learning basically. Yeah, so that's it.